I'm not sure if there was anyone supposed to introduce me, but I'm Bill Toffler. I'm in my 746th month of gestation. So why don't we begin with prayer, if we could. In the name of the Father, Son, Holy Spirit, amen. Heavenly Father, we know you're the author of all life. We've transgressed as a culture in respecting life, your creation, and all of its stages. Help us all be witnesses to the truth. Open our ears, our minds, and our hearts to your love, and to be loving to all of your creation. In your name we pray. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, Son, Holy Spirit, amen. So I'm blessed with the opportunity to talk about a different topic than the end of life, which is my normal motif at these conferences. Gail had actually invited me and then fired me because she knew my wife had a cancer that's not a good one to have, and thought we should have time together, and I was very appreciative of that, and I said, gee, thanks for thinking me, I've done this enough. And then my wife got upset and said this is where we needed to be, and so I should give credit for my being here to Marlene, who's sitting in the fourth row back there. And so but of course I had already given the recommendation of my good friend and colleague, Dr. Chuck Bentz, to do the end-of-life talk, because no one's more masterful at that, and any of you got to hear him earlier can attest to that. I see a lot of nodding around the room. So I had to go to the other end of life, and that's what I'm talking about now. And it's an important topic because there's so much misinformation about it, and it's really a shame, because there's so much good that can be done if people were aware of what I'm going to share today, and what many of you I know in this audience are knowledgeable about. And yet, if we can simply articulate what we're going to be talking about in the next 40 minutes well to each other, to our colleagues, to our families who are misled, then I think a great deal of good can come. And I want to share that excitement with you in the hope that already is happening, and I'll share the evidence for that. And I just want to add fuel to the fire that I see happening already in our culture. So my objectives are pretty simple here. I just want to give you a little background, because often these terms get interchanged, misused, and it is directly confusing. It reminds me when I was debating Derek Humphrey one time, and he kept shifting terms on me, and I remembered that he'd written about that in his book, not Final Exit, but Lawful Exit. He talked about doublespeak and how you want to just confuse people with these terms. And I pulled that little copy of that chapter when he was talking about double effect at the end of life, and pointed out, Derek, why would you want to confuse the people that we're trying to inform and educate about the end of life and appropriate end of life care? So I'm going to share the background and real terminology. It's not as complicated as you think when you really get at it, and I hopefully make it clear for everyone. And then I'm going to go through some myths, and I picked 10. They're actually on page 19 of your booklet. Is not my handout, but very close to that. I think they show 7 myths, and you can kind of follow along and see if I cover all those or not. And then I want to talk about truth, because there really is an absolute truth. Gravity is down, it's not up. There's a difference between males and females, and there is a need for us to acknowledge the truth of when life begins. I don't know if you ever heard the succinct discussion that Pastor Warren had with our 2 presidential candidates before President Obama was successful in his bid for the presidency. But there was a long rambling answer about when life begins from our current president, and ultimately he ended his rambling equivocation with, it's above my pay grade. And then John McCain got asked the identical set of questions by Pastor Warren, and he said at conception. And it was so stunning, the difference, the contrast between the two answers, that it kind of took Pastor Warren back, and the audience burst into spontaneous applause at the clarity of his answer. They couldn't help themselves. And Pastor Warren said, well, I guess next question. It begins at conception. And we've heard that earlier today as well. So the human body is kind of a miraculous entity. All of us sitting in this room have over, not just a trillion, but up to 100 trillion cells that constitute the form you're seeing in front of you speaking now. You know, I confused this trillion when I saw the trillion that was our national debt. And, but there's that many cells. I guess if we had $1 for each one of our cells, we'd be on our way to overcoming the crushing death. It's a complicated thing. But we begin as a single cell. And you heard that earlier today. A gamete joins with, well, two gametes. One's female, one's male. And they share their nuclei. And this is a scanning photomicrograph that shows, and you can actually look and see the faint double circle of nuclei joining together, 23 from each, and you get 46. And then that is a unique human that never before was and never again will be. And that's in a single cell. That rapidly goes through a division process. Immediately it becomes called a zygote and up to a morula, and then blastules are Latin terms for different stages of human life just based on the number of cells. That's the only difference. Otherwise, it's still the same human, same genetic material. And then it goes from being totally able to be differentiated, totipotent, if you will, into already within a few doubling lives into pluripotent, where you actually have cells that have already formed the part that's going to be the cocoon, if you will, the trophoblasts that go into the uterus. And then the part that's in blue here is the inner cell mass that is the one that is so much interest to scientists ever since, what year? What year do you think this whole stem cell morass began? Not that long ago. It was 1997. And it was James Thompson, who's a University of Wisconsin researcher, who cultivated and was able to culture this inner cell mass and grow it. And yet, we've been working with stem cells for a little longer than 1997. When was the first one? Well, bone marrow transplants are stem cell transplants. We've had those for over 30 or 40 years, and they've been successfully saving lives. The new kid on the block is really the embryonic stem cell, and that's important to know because this is not a new phenomenon. It's only this taking them from embryos, and embryonic stem cells is the new phenomenon. So that's the difference, and you can see where these stem cells come from. At least some stem cells come from, right? Everybody clear on that? Okay, good. All right, so what's the difference between a stem cell and all the rest of the trillions of cells that make up our bodies? Well, stem cells can produce other cells, and that's not necessarily unique, but they can proliferate without specializing. They don't have to become particularly in one organ, kidney, liver, eyeball, retina, whatever else. And that's what's unique about them. Now, all the other cells are body cells, somatic cells. You have different terms for these things, but they have specialized functions. That's all that's difference. Now, one source is what I've talked about, where you take a fertilized egg and you have it double, becomes totipotent, ultimately differentiates into that inner cell mass and the trophoblasts that go and form the placenta and form the cocoon, if you will. But they take these inner cell mass and they culture them and they propagate. You get up to hundreds of millions of cells. Now, this is being done with this source of stem cells. But there are other sources of stem cells. I'm going to get into that. And I want to give credit to Father Tad. We often just refer to him as that because his last name is somewhat unpronounceable unless you're Polish. I'll take a crack at it. Pachalczyk. Polchik. All right, well, with due credit to Father Tad's unusual last name, he's probably the most knowledgeable person that I've ever heard speak about this topic, and I'll have to give a lot of credit to the thoughts that I'm sharing with you to him and the National Catholic Bioethics Center, which is a clarion of truth on this issue. So, first myth, stem cells only come from embryos. Well, they do come from embryos, as I've just pointed out in a couple different slides. They can come from abortions, but they also can come from miscarriages. So that same sort of source. You also, of course, there are hundreds of thousands. Nobody knows the real number for sure. I've heard as high as 400,000. I think it's probably low. Frozen embryos. These are people who've actually had in vitro fertilization outside the woman, and then the nucleus that then can grow into different stages can be frozen in minus 160 degrees centigrade and kept virtually indefinitely. So those are all sources. Now, of these, actually, I'm only listing one that doesn't actually deliberately interrupt or mess with human life, and that would be the miscarriage. But there are other sources as well. In pregnancy, and we've heard that many people in the room here are fortunately doing exactly what Scripture tells us to do, is be open, be not afraid. You could get embryonic stem cells from the amniotic fluid. You could get it from the umbilical cord. You could get it from placental tissue. We throw away these things. It's just loaded with stem cells. Now, it's not the only sources, though. You can get it from the bone marrow. I've already mentioned that. And that's successful and already saved countless lives in the world. But you also have other abundant sources, for example, fat. I have some of that myself, and I'd be glad to donate it. But there are stem cells in all tissue, and your skin cells. I'll never forget Michael J. Fox. I got it right this time, Marlene. I always want to say Michael Jackson, but it's Michael J. Fox and Oprah Winfrey, and her favorite doctor is Dr. Oz. Everybody knows. So they're talking about this, and Dr. Oz actually tells the truth. He says exactly what I'm saying, that the new exciting frontier in this is to take Michael Jackson, some of your skin off here, and we just take it off and we induce it backward a little bit so that it becomes more pluripotent. We can actually then coax it to become heart tissue or brain tissue, like the tissue that's missing that causes Parkinson's. And he says this on whatever international TV that Oprah's on, and her jaw is just, and Michael J. Fox's jaw is just, and they're both, because they've both been some of the leading proponents. Michael J. Fox, as you know, is kind of like the poster child for embryonic stem cell research. Now, he's well-intentioned. I have no animus. He's a fine actor. Even with his debility, he still is a fine actor. But he's well-intentioned but misguided on this issue. And Dr. Oz was trying to correct him. He actually said in the next 10 years, I don't know about Dr. Oz being right about that, but we're going to have what Dr. Oz suggested from his stem cells, from his skin. And the reason that that's so effective is because the skin, if you took it from Michael J. Fox, would be something that he wouldn't have to worry about rejection, would he? And you wouldn't have to worry about all the multiple steps to try to get these embryonic stem cells to do what you want them to do. Because the problem with them, one of the downsides of embryonic stem cells is they're very uncontrollable. They're kind of like the difference between a graceful 747 jetliner that just nudges and a fighter jet that can go in all different directions, but this would be a fighter jet with no controls, if you will. So there have been peer-reviewed studies, like with Parkinson's disease, where they've taken embryonic stem cells, injected them in the brain with the hopes that they're going to know what to do on their own. And what did these embryonic stem cells do on their own? Whatever they wanted. They formed teeth and hair, and they literally had these things growing in someone's brain. Now, this is in the medical literature now. The author of that study said something I've never seen an author say, either before or since, in a peer-reviewed journal, was this experiment should never be replicated again in humans because it was a disastrous outcome. And people in general did worse, and there was no evidence of benefit. It also can be taken from olfactory tissue, and I'm going to focus on this quite a bit in the presentation. Olfactory tissue is the nasal smelling nerve cells that give us the sense of smell. They're in the top of your nose. They're very close to the brain and very close to the spinal cord kind of tissue, and that's important because it's actually been used now with people who've had paralysis of spinal cord injuries successfully. You can even get them from cadaver tissue. You can get it from heart muscle, and I'll show you a little bit about that as well today. It's exciting the number of fronts in which we're making headway, and yet none so far with embryonic stem cells. So another myth is the church is against stem cell research. Well, it actually isn't. It's against any stem cell that comes from a source where you have to end the life of one human in order to help another human. They're actually in favor of about 9 out of the 11 total different sources of stem cells, and they would encourage research in those areas. The church is not against stem cell research. And yet, again, like Derek Humphrey with his doublespeak, the side that is promoting embryonic stem cell would do like nothing better than have you confused about these terms. So these are different sources: embryonic, stem cells, germ cells. Umbilical cord cells would be just fine. No life gets destroyed any more than if I donate a kidney, God forbid, to one of my family members who needed to have one. That would be a life-giving thing to do, and that's fine. Adult stem cells we've talked about. So the number of patients with this myth 3, embryonic stem cells have the greatest promise. You hear that all the time. That's why the state of California took from the tax rolls of the people of California, a state, one of our largest states, like the sixth largest economy in the world, the state of California, awash in red ink, took $3 billion from their taxpayers to fund this research, which has resulted in 0 patients being helped by the thus far 14 years of research that's being done in this area. On the other hand, the legitimate sources of stem cells have helped people with heart attacks, and I'll show you a little bit of that today, leukodystrophy, and lots of leukemias, because this has been going on for years, decades, in which people have been getting stem cell transplants, sickle cell anemia. There's an effort now to actually purge the marrow of the dysfunctional marrow and give people stem cells, their own stem cells from places where they're actually having good production. And then spinal cord injury, it's very exciting, and I was not aware of this before Father Tad showed some of the slides of this, and this is what's happening with people with quadriplegia and paraplegia. This is particularly in Portugal. Dr. Lima is doing this. He's taken an injured area, they cut out the scar tissue, take some of the olfactory cells, culture the adult stem cells from that person, and then introduce them into the severed, damaged area of the spinal cord, and they're actually growing new neural links so that people are actually getting feeling, sensation. They're also getting muscular movement in areas where they didn't have them, and it's striking. This is actually one of those patients. It's Laura Dominguez. This is Dr. Carlos Lima up there in the upper left of your screen, and she's doing push-ups now. She was a quadriplegic from an accident, and this is her with some assistance with a lot of intensive PT. It's not like this is some magic thing. You just do it and instantly the person's back in shape. But the very fact that someone like Christopher Reeves, who was the other poster child for this embryonic stem cell, had he devoted attention to what really was working and put his considerable persona to work in trying to highlight this, I think we'd be in a very different place. And in fact, you could even dare to say, depending on the timing of things, Christopher Reeves could still be with us. It's not possible for anybody to say that with assurance, but I want to show you a little tape if this comes through and if the sound works here or not. It may take a while. This is Laura Dominguez herself, who had the accident. What this is doing is, until the sound hopefully comes on, is describing the scene of going through the highway with her friends and the car lost control.
The car kind of swerved back and forth, and we hit the concrete divider that separates the two highways. We hit that head on, going about 65, 70 miles an hour. I remember I woke up, I was in the car, my head was laying on my shoulder, and like my ear was touching my shoulder. I knew something wasn't right, and then the next thing I know, these paramedics come to the car, and they ask me what's going on, what happened, what I feel, what I don't feel, and I told them I don't feel anything. I think I heard one of the paramedics tell some other guy that he had to get a neck brace because I had broken my neck, most likely. So we were rushed to the hospital after that, and the doctors told me that I would never walk again. I thought it all was a bad dream. When I was first injured, I didn't really want to do anything. I just wanted to lay in bed, and I guess in a sense I felt sorry for myself. From the very beginning, my parents started looking at, different alternatives for spinal cord injury, different therapies and stuff. Then we heard about a new cutting-edge procedure by a surgeon in Portugal named Dr. Carlos Lima. They took cells out of my olfactory mucosa and they cultured them somehow, and they opened up my injury site, they took out scar tissue, and they laid the cells in there and closed it back up. I think the thing that I noticed the most from Dr. Lima's surgery was my feeling. Before I couldn't feel from here down, and now I feel all over. It's just patchy. In some areas it's normal, in some areas it's kind of numb. The more movement I get, the more, whenever I have a good day in training, I'm like, oh, I couldn't do that a week ago, or I do something new, like I might move a foot or a toe or something like that, or It's very inspiring, and it drives you to go forward. Now I'm able to stand, I walk, I do so many things that I just never thought before that I would ever do. I'm gonna walk again. That's pretty, 4 words, it sums it up.
My name is Laura Dominguez, and adult stem cells are going to help me walk again.
That's a good website there, the stemcellresearch.com. I think it's listed in your brochure as well. You know, God provides. I didn't actually prepare a handout, and then I opened a brochure to page 19, and there it is. So there you have it. I can't take credit for it, but it all works out. All right, so what else? It's not just spinal cord injuries. There are literally 70, I've heard as many as 96. Actually, Father Tad had one of his research assistants try to go and actually document. He said 96 now was the latest. Of course, I don't have the list of the 96, but I can tell you the score sheet of 70 or 96, whatever it is, and 0 is very telling. It's not to say that you can't ultimately control embryonic stem cells, but right now that is not the case, nor is there any immediate hope. Even the people who have pushed embryonic stem cells from the beginning acknowledge, the ones in California particularly, said we really oversold the message, if you will. So I'm going to show you one more little short clip. This is with heart attack, and this is literally where you can take from an individual who's had a heart attack, a little biopsy of his normal heart, a little tiny piece of heart muscle, find stem cells, culture them, and then inject them back into that person in the damaged area of the heart that was not contracting, it's non-motile or even beginning to scar, actually acts like a beacon, if you will, and these cells, which are not embryonic, they're not so erratic kind of cells, they're heart muscle cells already, and they find their way and actually grow and begin more normalized function in that damaged heart, and I'm going to show a little bit of that, hopefully.
There are almost 1 million heart attacks per year in the United States. About half are fatal. Eddie Floyd had a heart attack a couple of years ago. He's the owner of the Bark and Purr Pet Center in Austin.
I had a very, very strong pain from armpit to armpit, and so I knew what it was. There wasn't any doubt what it was. It was extremely painful.
He did develop the typical chest pain, came in, treated in the typical way, which was to open his artery and put a stent in, and then use all the usual medications that we would do.
The doctor came in and asked me if I wanted to participate in a study for adult stem cells that came from people's bone marrow.
And within 10 days in that phase of the trial, he received either the stem cells or placebo. We know in his case that he got stem cells.
You know, I went home from the hospital and went back to living my life, except for going in frequently for checkups.
The typical heart attack occurs when an artery to the heart gets blocked. Without blood, that part of the heart dies, leaving it scarred and weaker, reducing its pumping power.
Then we look at an overall heart function assay where we talk about the ejection fraction, which is the percentage of blood that's pumped out each time the heart squeezes, and that ejection fraction improves in people that respond. So 3 different parameters really: the size of the scar, the activity of the muscle, and the overall strength of the heart.
They did not cause any kind of rejection, so I didn't have to have any rejection preventing medicine or anything like that. They were just generic stem cells that became heart.
Within the first 7 days after a heart attack, the heart cells that are dying are emitting homing signals, a beacon that says, I need help, and the stem cells are able to respond to that. And we do that to a small amount anyway when we're trying to repair our own heart attack. But in this case, we're giving patients millions of stem cells that can recognize that homing signal and travel through the veins, through the lungs, and then make it all the way to the heart. And we know that this works. They become myoblasts and then myocytes, and they have been shown to actually be truly functioning heart muscle at that point.
And it has apparently regenerated the muscle that died during my heart attack.
He was one of them that had complete resolution of the heart attack. You couldn't see any evidence of damage when it was over with, and he had normal heart function. So he did have a pretty dramatic response.
There really isn't anything that I can't do because of my heart that I'm aware of. There are a few things I can't do because of my belly, but there are not many things that I can't do because of my heart.
In this study, the stem cells are harvested from healthy adults between 18 and 30. All the donors can become universal donors because the cells are processed to remove elements that cause rejection. The heart attack victim just gets the next cartridge given in an IV. This is an incredible breakthrough. In most transplants, they take great care to avoid rejection, but here there's no need for DNA matching or anti-rejection drugs.
Over 1,000 patients have received these type of stem cells, these allogeneic mesenchymal stem cells from healthy volunteers. There were studies done for Crohn's disease and graft versus host disease and a number of other disease states. In the heart study that was done in phase 1, there were 53 patients in that. And then this phase 2 study will have 220 patients. And we're dosing the second patient today.
The Texas legislature is considering pro-life bills, Senate Bill 73 and House Bill 2379, to promote ethical, life-saving adult stem cell research and treatments. As Texans, we have a choice. We can support adult stem cell research, which has proven to help many like Eddie, and successfully treated thousands more with over 70 other medical conditions. Or we can fund embryonic stem cell research, which requires the destruction of human embryos and is yet to cure any disease. Embryonic research is the choice of California, spending $3 billion. Their first goal is to restore function for one disease in the next 10 years. Research has been ongoing for more than a decade with embryonic stem cells, which has the dangerous side effect of frequently causing tumors in lab animals. Contrast that to adult stem cell research, where doctors continue to find positive effects on even more diseases.
A lot of the patients were smokers and had chronic bronchitis or emphysema, and it actually healed some of that process. And so over time, lung function improved in the people who got cells, whereas it didn't improve in the placebo patients. So now the company's actually started a whole nother round of studies looking at treating emphysema with it.
Please help put patients first in Texas. Visit TexasAllianceForLife.org and learn how you can encourage your state senator and representative.
Okay, so don't just move to Texas. We need your work here. So actually, I'd forgotten which video I put in here. The one I said when you actually take a biopsy of the person's heart, that's another technique. They're actually using here undifferentiated stem cells from bone marrow of healthy volunteers, like they said. So I misspoke earlier. I want to clarify that, but both are being done. Okay, so myth 4, moving right along. It's against the law to do embryonic stem cell research. Actually, it's not against the law. There's no federal law, and some people think that these kinds of things are protected, and yet there's not. Just like many people are of the delusion that Roe versus Wade just means that you can have an abortion for the first 3 months of pregnancy, and the truth is you can have abortion anytime for any reason up to the time the baby passes through the blessing of the birth canal in the United States. All right, so a lot of people don't know that. They really just don't know it, and they think that there's some laws protecting against this kind of thing. Myth 5, it was President Bush, the evil President Bush, who created new restrictions to federal funding. Well, that's actually not true. Not only is President Bush not evil, but also it was not him. It was actually during Clinton's tenure as president, his 8 years in 1996, that the Dickey Amendment was passed, and it was actually banning federal funding of stem cell research. President Bush, on the other hand, if you ever want a good read Decision Points by President Bush, but he has a huge chapter of the major decisions he made was trying to struggle with whether or not you should fund embryonic stem cells. He did not take this lightly. Now, he didn't come on a decision that's completely in sync with the Vatican. In fact, he was criticized the next day by the National Catholic Conference of Bishops and their spokesperson because it wasn't a pure statement. But he did say there were going to be no new stem cells, no new deaths to develop. He said you could use the existing 60-some lines that were available at that time. And actually, if you think about it then, President Bush did not restrict anything. He liberalized, for the first time in the history of our country, federal funds were going to be used to support embryonic stem cell research on the lines that already were done. But no new lines, it's not going to be an encouragement to do new ones. This was his compromise kind of decision. You follow me? So it's absolutely wrong to say that it was Bush's restriction. It was Clinton's restriction. I'm not blaming anybody or praising anybody here. I'm just trying to state the facts here. You follow me? This is a political discussion. All right. So, myth 6, therapeutic cloning and reproductive cloning are very different. No, they're really not. They both create an embryo by the same technique. The only difference is that with reproductive, you're trying to actually implant what you've done into the uterus and grow a human, or grow a later stage development human, whatever. And therapeutic is you're going to go ahead and take that embryo and destroy it in order to be able to harvest the cells. But the technique is identical. You follow me? Now, this is very important because our current president says in his famous stem cell research statement, we need to resist the false choice between sound science and moral values. So he's dichotomizing, like, you can't have these two things, and we don't want to ever have morality trump science. 2 minutes and 12 seconds later, he said, we will need to ensure that our government never opens the door to use of cloning for human reproduction. Now, what is that? I actually agree with that, but it's morality trumping science, isn't it? Like it should when you have Nazi cold water under experiments. So, well, these prisoners are going to die anyhow, so we might as well learn from them, right? That's what we did. At Tuskegee, where there are people who had syphilis, and they decided rather than treating these black people in Tuskegee, they actually just saw what would happen with a natural history of syphilis. Now, we don't really know that in our generation, but that was a horrible thing. There were aortas that got dilated and literally ruptured through chest walls. This is the kind of thing with late-stage syphilis. There's dementia. There's all kinds of horrible things with not treating. And we learned that we should have had morality trump science. So for the sitting president of the United States to make something about the false choice between sound science and moral values is just breathtaking. It wasn't just me who recognizes this thing. Charles Krauthammer, who actually is a syndicated columnist, many of you have read him in various papers across the country or the world, he actually is in for stem cell research, and yet he recognized the specious logic and just ripped to shreds the logic being emanated from our current president. You know, one of the people, I gave a talk about this a couple weeks ago, and one of the people came up and she said, I think I'm taking things out of value. Well, I encourage you to go on to Google and look at his speech and see if I'm taking this out of context. These are the quotes. The time is pretty close. It's 2 minutes and 7 seconds or 2 minutes and 12 seconds between these two statements. And then even though he disagrees with President Bush, he praised President Bush's 11-minute speech that he gave on a Thursday. I still remember it well because I gave a talk on this just shortly thereafter to a Legata Society about this very topic. And Krauthammer praised Bush because it was such an elegant discussion of the logic on both sides, giving strong, credible arguments for both sides, and the reasoned logic of people who earnestly disagreed with each other, weren't bad people, that you couldn't tell what he was going to decide until the last 3 minutes of the speech. And you contrast this with the pejorative language that anybody who disagrees with me is obviously, imposing the morality in the face of science, as opposed to your thoughtful humans trying to avoid what pitfalls the human race has had over the last couple of millennia. So where are we now? Well, they're coming up with new ways to try to use embryonic stem cells so that they'd be seen as legitimate. So they come up with this very complicated term, SCNT, or somatic cell nuclear transfer. And I'll go through this a little bit because you'll see the similarities in what I've been talking about all along. We just changed the terms. So here you got a couple gametes. That's familiar, isn't it? All right. You got one that's female, and the other one, because you're going to take the nucleus out of this one, so the other cell can be actually a more differentiated cell with all 46 chromosomes, and you replace the now vacated nucleus up above with a new set of chromosomes from, say, Michael J. Fox or whatever. You follow me? Now you got a little Michael J. Fox cell. But you got a new human, if you will. You follow me? This is the problem with this whole thing. And again, the nucleus removed, you get the new nucleus inserted, you get now the same terms, the zygote, then you get the morula and the blastula and all those things on down the line, and then you've got a little clonal embryo. And what do you do with that? Well, you want to take that little clonal embryo and you want to, again, get the inner cell mass. You see that similar picture there? Get some of those cells out, plate them, and now you've got, again, a destroyed a human entity that you kind of did in vitro instead of going through the normal process. And then you hope to cultivate it into bone tissue, muscle tissue, nerve tissue, heart tissue, whatever you want to do. You follow me? This is very similar, isn't it? But you got to destroy that new being that you created artificially, right or wrong. All right, so somatic cell nuclear transfer is different from cloning. No, it's really just another way to get at cloning is what it is. So that's another myth, all right? 8. It's direct production of tissue and organs without cloning. Well, no, you can't do it without cloning or harvesting an embryo and its parts, destroying the embryo and parts. So again, it's not ethical from the standpoint of the ethics that ought to bound science, or else we're dangerous to each other. We start devaluing each other, just as the unborn human has been devalued because some people don't want to label it a person. This is the same set of logic and tools. All right. 9, every cell in the body is an embryo. Well, no, really it's not. Every embryo is an embryo, and cells on my skin are my skin, and I've told you they have properties that you can do and use them for good purposes, yes, but they're not embryos, all right? And scraping cells from the skin will just grow more skin. It's got to be coaxed or induced or something done with it to get it to go in a different direction. It's already differentiated. So you go from this of totipotent, where it can do almost anything, to pluripotent, where it can do certain things, to organs and systems that have actually formed into a particular type of tissue. And you can try to encourage things to go backwards, but you really don't get a skin cell going backwards. You might get a stem cell in the skin to work as you want it to, but not just a simple skin cell. You follow me? Everybody follow me? Okay, good. Myth 10, using frozen embryos is okay because you've got hundreds of thousands of things, and a lot of these are going to be discarded anyhow, so we might as well learn from them. Well, you've already heard me speak about the horrors of the 1940s where, well, prisoners are just going to die anyhow. Kevorkian saying, well, this is what we ought to do, is offer prisoners the opportunity to participate in research. This is incredibly twisted logic where you dehumanize and you devalue some part of the human family because it's smaller, it's less developed, all those things in that SLED acronym that we heard about for those of you who went to that excellent session by Alan Lehman, thank you. Schliemann, I'll get it eventually. All right. The brain's older, it works slower at this time. So, all right, so there are different visions of scientists today. There's the people like now Dr. Oz, who's a convert and realizes that you want to do take these disease-free cells, cultivate from a patient, and then go into therapeutics with adults right away, and this is already working. This is not rocket science in the sense of it can't be done or it's just a theory. It's actually happening, and you've seen already living people with this. Lima's already up to 100 patients that have actually got these spinal cord treatments, and some of them aren't successful. I mean, this is like all things in medicine, and some of them are just like Laura, who's a remarkable, miraculous kind of a recovery. You can go online and actually find cases of somebody who went to Dr. Lima and it didn't work, and then he had embryonic stem cells that were just sent in his body, and he claims they work. Now think about this, though. It's not happening instantly. First she gets feeling, it takes months of intensive work, and if you have something happen to you 3 months later after you have a treatment like this, it's possible that the adult stem cells that came from the cribriform plate, the smells, were actually the ones helping. So it's amazing how, if there's an exception to what I'm saying, it's immediately held up to see it doesn't work, with no attention to the overwhelming numbers that show that there is huge hope and promise. So I want to try to give full disclosure on both sides. But then there's a group of scientists that want to go this other end run, if you will, where they're complicated, increase the complexity, where you have to transfer genetic material to an egg, you have to do cloning therapeutically, you got to culture it for days, you got to get the stem cells recovered, and then you're going to plate them, and you're really back where you were with all the new problems of rejection and all of the problems that are inherent in that. So there are different visions. I prefer to take the one that seems to have worked and shown all this promise, and I think anyone who's sentient without some bias or funding stream that they're trying to keep going would say the same thing. Now, the good news I want to tell you is that the state of New Jersey, who just emulated, thought California is going to get ahead of us, and they devoted also hundreds of millions of dollars to embryonic stem cell. They've reversed themselves, and they've actually gotten sense as the budgetary. I don't know if it's Governor Christie or what happened. I don't know the details, but I do know that they're not going down the same path fully with California. People who are pro the funding say things like, we can cure diseases. It's the Michael J. Foxes. It's the Christopher Reeves. We can establish rules. We can keep this under control. Like Obama said, we'll do all these things, but we'll never support cloning. Well, it depends on what you define cloning as. And we've got to protect American competitiveness. Well, American competitiveness does very well if you leave individual pharmaceutical companies and research companies alone and don't misdirect them. Now, I didn't tell you one of the things that happened in the middle of the night after Obama gave the green light to fund all embryonic stem cell research. What did he do that night? You didn't hear about this in the New York Times, but he cut off funding for all of the other alternative sources of stem cells that Bush had tried to encourage and fuel, was to try to not hold back on stem cell research, but encourage it. Not only did he open the floodgates of federal funding for the existing stem cell lines, but he said, let's spend hundreds of millions of dollars on the other approaches that aren't ethical quagmires. And that got stopped. And you have to ask yourself, even if you're for embryonic stem cell research, why would you stop the funding? And I'll leave that for you all to muse. Oklahoma voted 86-8 to pass the American United for Life model bill banning and destroying embryos for research. So there's great hope with clarification and education. Father Tad came here and testified before our own Oregon legislature, and he is so articulate and convincing that that bill never went anywhere. And Oregon is not in this morass of states wasting tax dollar money on this unethical approach to research. What does the church teach? Well, this is the Catholic Church. All human life is sacred. It's also most every Orthodox religion in the world, whether you're Muslim or you're Christian of one faith expression, you're a Mormon. People recognize the inherent value. I work with Physicians for Compassionate Care with people of very different faith backgrounds because we all recognize the inherent value of all human life. So it's very clear. We need to stop treating human life, even at its earliest stage, as biological matter. You've heard that, the term products of conception, dehumanizing others. They're not persons. You know, the 3/5 clause in our Constitution for people with extra pigment, melanin in their skin. They could only vote, they're only 3/5 the vote because they weren't really persons, not full persons, they're only 3/5 persons. I think I have that percentage right, don't I? Yeah, it's for the scholars in the group. All right, it appreciates and encourages ethical alternatives to adult stem research. So the church is not against stem cell research. It's against unethical practices, that's for sure. But the idea of saying there's a dichotomy between people who are religious and people who are science is absolutely wrong at present. It's wrong historically. Many of the great scientific contributions of the Western Hemisphere came about because of scientists who were very religious people. Yeah. So what can you do? I hope today I've shared a little bit of the understanding of the terms of the debate, discuss what's at stake, hopefully to educate your misinformed family members, relatives, ultimately your state legislators. Carefully evaluate legislation, support total bans on cloning and destructive research, and support ethical research because there's more of that out there than the other, even though the government's stopped funding for that. Now talk about stopping promising research. I mean, it's absolutely diametrically opposed to the accusations they're making. I mean, they're doing exactly what they're claiming the other side is doing. It's amazing. And if you want some resources in addition to what is listed in your brochure, conference brochure, the stem cell research organization.org is in there. If you want to look at what's for the research, there's also the bioethics.gov. Unfortunately, that's a government-sponsored website. And you can look at the other side that perhaps I haven't presented so robustly here today because I don't think there's much scientific evidence to support much of a robust apologetics for that. So I'll close there. These are just beautiful scanning 3D pictures of embryos to show that there truly is human life, and all of you should ask your doctors for 4D or 3D ultrasound so you can get real baby pictures, not these blurry, fuzzy white things. So I'll stop there and get thoughts. What thoughts have I triggered in your mind? Yes? Right, so the question is when you clone just one parent's genes or chromosomes, it is not the same as if the two parents came together. That's absolutely true because normally the normal process of normal biology is to take half of the genetic material from the father and half from the mother. And so you have the quandary of essentially, you know, cloning Dolly, if you will. You're getting another adult who's now become that person, and all of those genetic characteristics are there. And people see this as a great boon because then you can actually use the kidney from that person, and you see the utilitarian model. And unfortunately, if you read the history of Dolly's sheep, what happened to Dolly?
She died of old age really fast.
She died of old age really fast, and there are things that you go down this path, and you know there's a concept in medicine called apoptosis. It's a tendency for cells to be programmed to death. And so you go mucking in one area as though you're going to be making something beautiful, and it's really got its own set of problems that we haven't even dreamed of. And there's been at least fledgling animal research in this area. But the hopeful thing is I'm seeing even people who are dabbling in this embryonic stem cell and this cloning technology, many of them have either, one, been discredited, or two, say this is really not the path of promise, and they've switched. Not all, of course, because you still see the push at the federal level in the politics of today, just absolutely reciting the mantra that you heard from, I think, well-intentioned people like Michael J. Fox and Christopher Reeves and Nancy Reagan, who thought her husband's Alzheimer's was going to be cured with more money being thrown at embryonic stem cell research. So it's a very good question, yeah. Yeah, it's a great question. So what's being asked is you can take stem cells from umbilical cords or amniotic fluid, and you sure can, and that's actually going to be genetically, especially the umbilical cords are going to be genetically identical to the baby, and you can actually freeze that, and that's already happening now. You can actually, for relatively low cost, freeze the material that could be used if the baby had, or the adult 20 years from now has leukemia. You're absolutely right, and that's actually being done, and it is not prohibitive in terms of cost, and it is totally ethical. There's nothing wrong with essentially, working on a prevention of, or a way to deal with a disease that you might get, that you might lose $100 a year or whatever it costs to keep the cryopreserved material, genetic material. And that's okay. That's not a problem. Again, what's a problem, if you want to step back and say, when is it a problem or when is it not? Are you ending a human life? And the idea of taking material that's not a human life, it's just essentially the knowledge, the directions, if you will. It's kind of like you have directions on the inside of your refrigerator. If it breaks and you open up the door and there's a panel that tells you what's the algorithm to go through to try to fix the creature. That's exactly, you're sort of doing something preventative, and that's why they put those things in there, because they know that they might break, and then they do this as a way to get through that problem more easily. This is exactly what that would be. It's a great point, and it's totally ethical. Yeah, so the question is, can you use stem cells to regrow legs and things that don't naturally regrow? About the only thing that a human will regrow, like I've seen injuries with fingertips and all where you thought that there was going to be nothing there and the person grows back beautifully. But if you take off at the level of, you've had that experience?
My husband about eight weeks ago.
Yeah.
This much of his finger, and now this much is back, and it's slowly grown itself back.
Yeah, so with that kind of exception, most of our human body parts don't regrow. If you have a total amputation of a finger or a limb, or that famous surfer picture that had her arm bitten off by a shark. Right now we don't have the technology. Is there promise for that? I think that's more along the lines of any hope with embryonic stem cells research. Even with the other legitimate sources, I don't see work being done, or at least in human trials where that's happened. But is it possible? Possibly. I would say that it's you've got to give direction now, not only to grow a tissue, but to grow it in the right organizational pattern, and that's almost a system thing where you have bones, you've got arteries, ligaments, and the complexity of that is like the complexity of making embryonic stem cells work. It's very complex, yeah. Yeah, in the back, yes. Yeah, so I think you're asking about the somatic stem cell transfer, where you're actually taking an egg, removing its nucleus, and then you're putting another nucleus with genetic material from, say, another human. And how does that work? Well, the problem with that, you then have one cell with, say, an adult, say Michael J. Fox's DNA. Now, you've got now, in an artificial sense, a new human, don't you? However flawed. And this is the problem. We're sort of making ourselves the God with a little g. And that, if left uninhibited, if you get past the technical steps of taking out the nucleus and putting a new nucleus, is going to essentially grow itself into a human. Now, Obama says, that's okay, because we'll just stop it. Well, that's identical to what we're doing right now with embryos. Now, granted, the one embryo came from, say, a mother and a father and an abortion. And this other embryo is one that you're creating of a human that's never been done before, but it's still an individual human. And that gets into that sci-fi thing that you see in movies about cloning, isn't it? I mean, it's essentially the path you're going down, which most people would say, don't go there. And that's why, again, I don't think there'd be many people from religious sense would say this is a good thing, yes. Yeah, so the question is, if you do that successfully, will they have the exact same DNA as the other person? And the answer is yes. Yeah. So anyway, you've been a very attentive audience. Hope this has helped you a little bit with this discussion, and you can be ambassadors yourself. Thank you.